We're starting stream number 10. Hi. We're building up the Rust version of the grammar for a compiler that I have, and we're up to 5.5 grammar rules. This expression rule, we only have, actually that's not the best place to look. Let's close others, and then look at the actual grammar. Expression only has one variant in it, and we didn't finish on that yesterday. The original grammar looks like this and has many variations. I just happened to pick out one of them to start with. I think I was also working on updating the lexer. Hi there, Nightshade Dude. How are you today? How's the dude? Okay, yeah. I think it's all within our lib here, right? Yeah, we're defining this location. And we have a lined in callback. And I had just written that and ran out of time yesterday. Working and cold. I know, it's a cold day today. At least where I live. Maybe you too. See if I can get the last thing I ran. Yeah, I guess that is what I ran last, right? Yeah, so we're adding location information to the lexer. Right now we have the spans where lines end. So let's continue. 44. Hopefully that could actually be very hot or pretty cold, depending on if it's Celsius or Fahrenheit. So yeah, what if it was 44 Celsius though? It'd be like in a sauna. That light rain would be like hot hail. Yeah, you'd be dead. No, you'd be cooking. You'd be cooking. Be slowly cooking in your own stews, I guess. Okay, so the location, line end. Actually, line end's not the only thing, right? We'll also need to know what column we're in. I can't think that far ahead. Let's do line end, that's easier. So given that it's somewhat working, let's make sure it's working. So if I open the original format file, so that's 1, 2, 3, 4, 5 characters or 5 bytes. So the left brace would start no, that's the line end. The line ended at 5. So 0, 1, 2, 3, 4, 5, and then 6. So yeah, that means we want to set the position to the end of the span to be the start of the next line, right? Oh, one other thing we should do, I think, is not count carriage return symbols. Otherwise, we'll be one off in our columns if we have a new line followed by a carriage return. Yeah, anyway, this would be position plus equals. Can you do plus equals on a reference? I don't think I can, but let's see if it lets me. Nope. So the alternative of that is position equals position, slice position and dot dot. Oh, no, that's not the reason. I should slow down and see what the reason really is. Position meant to be self position. Then the problem of that's not a plus, and then the overall problem that we can't do that. So it is like self position dot dot and then a borrow in front, right? Cool. Okay, we also want to do self dot line number plus equal 1 and self dot column number equals 0. Oh, this byte number needs to be subtracted from the span end, doesn't it? Right. Let line length. Actually, it's not the line length because I'm probably going to move position for columns also. Yeah. Hmm. 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 Names. Names are tough. So whatever it is, it will be that minus self dot byte number. Line length isn't a good name, but what is it? It's like how much we've moved since the last column. So like jump or something. Sounds good to me. Okay, now what if in that Lex program we actually print out the locations? I have to actually change I have to change something else, don't I? I have to change the type for iterator. It's not just token anymore. It's going to be like token with locations, right? And to be really compatible with the parser, it would be a tuple with a location. Well, wait a minute. Location's got beginning and end, right? No, location's just got one position. And it's got more than I need, so I want a different type actually. I don't want to call that location. Back up, back up. Hey there, Sarian. How are you doing? Let's not call that location. Let's call that location tracker. And then we'll have our location. Let's move this here. Okay, and then this is location. Yeah, I saw that you were going through the VOD. I'm impressed. You're getting your alternative Lexer working. This is going to be location dot. Okay, and then let's have location be copy. Okay. So that I can do location. Okay. Parser will be very different. I imagine so. You're not going to have a lazy Lexer? Let's see. Yeah, so let's make the iteration type have two locations in it. Then this will match what the parser wants, right? So it'll be break self location. Actually, we need to know the beginning of it. Right. So we need to get the location beginning and end from the two spans, from the span, right? Why don't we make that part of something the location tracker can do? So Yeah. We'll I just need a name for the thing. Something thing that given a span, not spam. Will not only advance the position internally, but also give us two locations. I wonder, I guess I don't need that then, right? Do I? So this would be like what to name the thing that given a span tells us the beginning and ending of that and also updates the internal position. Like find token? Find next token? Or how about next token locations? Next token begin end. Hey, dude, man, this is making you want to take another crack at crafting interpreters at Rust. Go right ahead. I'm glad to be inspiring you. Okay, so then I think internally we want a function that can like advance a certain number of bytes. So let's make an internal function called advance given bytes. So how do we do this? Given a position, we need to know how many bytes the next character has. That's not coming to mind immediately, so let me look it up. So Rust, how many bytes are in the next character of a slice? That's not true. Well, that's a character, but not in a slice. See what the answer is. Rust uses UTF-8. Character C, you can know they bytes it will take up in a slice. That's not doesn't answer the question. Okay. Actually, from a slice, can you call chars on a slice? Docs. That's not the right docs. I want Rust docs. Okay. Primitive type. As ASCII as bytes, can I can call chars on it. Okay, cool. That's what I want. I just want to do chars and then next, and then that'll tell, and then I get one character. Actually, will the character tell me how many bytes the Unicode representation is, though? Char indices? Ah, and their positions. That's what we want. We want char indices, and we just want to do a next, right? Or I guess we could just advance it until we get to the end position. And maybe if we get past it, we panic. Because a char indice is going to be see, where does it say? It's going to be like its implementation of iterator. Clone debug iterator. Yeah, it's a tuple with the position and bytes and then the character, right? Cool. That's exactly what I want. So I want let mute ptr, because it's a pointer, equals self dot position dot char indices. That doesn't consume it, right? I can do that, yeah, with a reference to self. Okay, so we're good. So then while actually I guess we don't even need to do this. We could do this functionally, right? We could do char indices or I can just do a for offset C in that. And then I could say if, well, match because if we're beyond bytes, panic. If we're at bytes, return. If we're below bytes, continue. So it would be a match, right? So it would be match offset compare to bytes. Offset is less than bytes, continue. Offset equals equal to bytes, return. Offset greater than bytes, well, panic. But what are we going to say here? Bytes or bytes points into the middle of the character beginning, well, into line, points into the middle of a character beginning. We're going to count middle of the character in column something. You make an interpreter? Yes, I am. Let me give a quick, very quick summary because I've done this like probably 100 times so far. But that's okay. We're getting new people all the time, and I love to explain what I'm doing. So I have a tool that can parse any kind of protocol or binary data file or anything that's raw bytes. So for example, let's see, we have a GIF file that looks like this, but to the computer it looks like this. And we want to write a program that can understand what's inside the file, like maybe like we want to extract the size of the image or number of frames or maybe the frame rate of the GIF. So I wrote a tool that you can describe the format of the GIF in like how to decompose it into its parts. So a GIF starts with a header, has a logical screen, some data blocks and a trailer, and the logical screen has a descriptor, and the descriptor, here's where we find the size of the GIF, right? So this is written in a what I call domain specific language, or DSL, where the domain is parsing data. And so it's not a general purpose language. It describes both the structure of the file as well as how to parse it. So there's like functional aspects to it, like there's loops, there's conditionals, but also overall the order of the statements kind of gives the order in which how to break the thing down into smaller pieces, right? And it's recursive. So header is a piece, but inside header there's a signature and a version. And this is what it actually looks like if I run it. So kind of showing side by side like the input file looks like this, GIF. So GIF is the signature, 89A is the version, and then the next 2 bytes is 44 and 1, But if you assemble them as a little endian 16 bits, it's 300. So that's the width of the image, right? And it's described exactly like that, right? So signature 24 bits, version 24 bits. Logical to screen descriptor has little endian 16 for the width. So there are three parts of the tool. The first two are basically the same as an interpreter or a compiler. And we're taking this input description, right, and compiling it into an abstract syntax tree. And that's in two steps. We have to do the lexical analysis, which is basically you turn that into, that's not what I wanted. I want target, right? Or is it cargo run? Nope. Hold on. I'll get this someday. I don't know why that wasn't in the history. GIF.format. Need to learn how to do these demonstrations a little bit quicker. Yeah, so we have the lexer turns the input lines and characters into tokens. And what we're adding today is the notion of like, for every token, it will remember where it was in the original file, like what line number and column numbers. So anyway, the first word GIF is an identifier, and then we have a left brace, and then we have an identifier header, and then a semicolon, and then a logical screen semicolon, and then we have the local, which is a reserved word, and then an identifier next. You kind of see how that goes, right? It's sort of half digesting the input program into a token stream. And then what we do with the token stream after that is we run it through a parser generator. So what that does is it matches strings of those tokens as fitting into the grammar of the language. So like if something is an identifier list, if it has identifiers, a comma, and then another identifier, right? An optional comma is either nothing or a comma, right? And when we match these grammar rules, we reduce it to data. So optional comma is no data. But like when we have a literal integer for the expression, if we have an integer and we're expecting an expression, then that becomes a literal integer expression. So all of the rules reduce down to a big tree data structure that then we'll walk through side by side between this data and that data tree and basically match it up, right? So we do an in order traversal of the data tree, and that'll say, well, the beginning is got to be a header, right? And that header begins with a signature. So these first 3 bytes have to be the signature. And the tool just methodically goes in order traversal of that compiled format, matches it up with data, and tells you, what's what. So I guess you could say it is the combination of a compiler and a matching tool because it matches the program with the data. Yeah, that's maybe the best description of it. So we're making a program that compiles something and then matches up the compiled form with a data file. I wish I could like find a better name for what I'm doing. I guess binary data analyzer, the best I can come up with right now. So this line is pretty long. The formatter's having a hard time formatting it. In fact, it doesn't want to format it at all, probably because this doesn't make sense, right? Probably I need to have that. Sorry. Yeah, is it because this is long? What if I do a concat? Let's put the concat up here. I'm a little bit perfectionistic, Concat makes me do a multi-line string like this. And then I found that will sometimes give the formatter an easier time. Is it not concat? Oh, no arguments named bytes. It was right there though. Maybe it's because I didn't fill anything in for that. So let's fill something in for that. That's self dot line location line number, self dot location dot column number. Okay, it still doesn't like that. Why not? Intend to capture variable bytes from the surrounding scope, format args. Argument name bytes. Okay, well, we'll just do this. I don't know why it didn't like that. I don't know. Anyway, what we're doing here is when we're given a byte count into the line, that we're moving character by character until we find what column it's in. So actually what we don't want to do in the continue is actually do a block of code here. Self.column location dot column number plus equal 1, right? Let me think about this. The first offset will be 0, right? And if that's the it's not going to be less than whatever the bytes is, so it'll always advance 1. And then hopefully when it gets to the actual number of bytes where a location, like between characters, they will actually be equal at that point, and we'll have advanced the correct number of columns, right? And if it's greater, that means we went into the middle of the current line and the current column number on the current line. I think this is correct. So then here what we need to do is we don't do this jump thing. I do a self dot advance span dot begin, right? Or is it span dot start? Span dot start, right? And then that should give me like whatever column and whatever the location is at that point. So let start equal self dot location. Then we advance to span dot end minus span dot start, right? Oh, this should be span dot start minus self dot byte number. And actually, byte number, I guess it's most convenient to keep that the beginning of the current line. No, actually, hold on. Let me think about this. It should be the previous endpoint, right? So this byte number should advance too. Self dot byte number plus equal offset, right? Well, hold on. No, it'll be well, there's going to be a beginning point. Let start byte number equals self dot. Actually, then hold on. I'm thinking ahead. I don't need to do it there. I would do it when we get to the equal case. Self dot byte number yeah, I want these all to be consistent. So this should just be equal to, no, plus equal to offset. Actually, if we know that, then never mind, because we could just do that anywhere we want. Like we just do it here, self dot byte number plus equal bytes. There we go. So it's always going to advance to the start, right? Let me think about this. The beginning, this is 0, and this will be some number like 5. So we'll advance 5 bytes. The next time, it'll be some number like 10, and 10 minus 5 is 5 more bytes. more bytes plus equal, right? Okay, I think this is correct. But I have to subtract here again. Okay, and then let end equals self.location, and then it's just start and end. Oh, okay. Right, so then here we want to ask location to do a next token begin end. Here, I guess, right? Start end equal self dot next token begin token dot span. Hold on. Self lexer span, that's what it is. And it's location dot, right? Actually, let me rename that. It's not a location, it's a location tracker. Okay. So yeah, then we're supposed to return start token end. Okay, what's wrong with that? Expected an option? Oh, yeah, shoot. Why is it an option? Oh, then it's just sum, right? This should be like, yeah, shoot. It needs to be break token dot map token to that thing, because it could be none. Otherwise it's sum, so I don't need that or that. There. So if token's none, then it breaks with none. If it's something, it'll be some token. We turn that token into its start and end around it. Okay. What's wrong with this? Location's private, so make it public. Public. Easy. Okay, so the unit tests for the lexer, we need to update this, right? Because now the expected output's not just going to be a vector of tokens, it's going to be a vector of tuples with locations in them. Right? And then we can't compare that because there's no partial equal for location. Well, why do we need partial equal for location? Oh, because the default one for the tuple is generated if we have it for all of the constituent parts. So yeah, if I do a partial equal here, that should fix that. Nope, it didn't. What's the other thing? It has to have the debug trait. Actually, let's custom allocate the debug trait because that I just want to do line number colon column number, right? So let's do a impl debug for location. What? What? Okay. Use standard format debug. Actually, maybe it's better to be explicit here and not do that use thing there. Okay. The default is to do that, right? Debug struct. Yeah, so instead we want to do f dot write string, write format, something colon something else, and that will be self dot line self dot column. Wait, what? So it's not right, it's like right, I think. Comma. There we go. Need to give it the output of the format argument so I can. No, I don't. I can just use the write macro. Tried writing Rust. It's been hard. It is hard, but it's kind of satisfying when you get it working. Cool. So now we can do that. Actually, while I'm at it, what if we also implement the display trait for it? Same way. Qualify as standard format. Okay. It's the same thing. Okay, so here's where it gets kind of tough because I got to put locations in this. So hey, let's see if we can do something clever. Let's do a 0, 0 into, and let's see if we can implement from slice for location, because all we need to do is parse the two things and have a colon between them, right? So like, and this would be 0, 2 into. Actually, even better would be if we didn't need the into, but we always need the into to get the type because Rust is a bitch, right? So yeah, so much for that. Let's impl from I forget if you put you don't put that in there, right? I guess you do. Then you need tests for your location parsing. It's test all the way down. Well, we're kind of I figured that we're testing it as part of the Lexer's tests for the various things anyway. So if there was a problem with that, well, actually, we're only really testing the column number, right? Well, actually, some of these have multiple rows. So there we go. We're going to be testing the line number stuff as well. Looking using the Instacrate, which does snapshot-based comparisons. Instacrate, huh? That sounds like Instacart. Okay, from value. So it's going to be value dot split. Actually, it's split n, right? 2 on that. And then is split n the right thing, or there was a easier one for like, yeah, I can't remember this. There's an easier one if you knew exactly the right number and then you get a tuple out. What was that? Search the webs. Rust split string into 2 parts. With given, no, I guess that's right. Like, No, that's not right. That's window or something like that, right? Or something else. I guess I didn't ask my question correctly. Time to ask ChatGPT. Chat.openai.com. Okay. How do I split a string into exactly 2 parts given a delimiter? How do I split a string in Rust into exactly 2 parts given a delimiter? What does ChatGPT tell me? You can use the split once method to split a string into exactly 2 parts based on delimiter. Thank you, ChatGPT. Split once. More and more, I'm thinking ChatGPT is the go-to search engine for me. So who was first? Get Off My Lawn or ChatGPT? You doing tests like this. Copy link and paste. By the way, I have to end the stream like 45 minutes from now. I got early work meetings these days. Test case that. Oh, that gives me an idea. I could let my function in here do the parsing of the line and column numbers, right? I can just give it strings. Clone current. Assert debug snapshot. Is that what we're looking at? Creates the snapshot and compares it using Insta for snapshot testing. So like instead of doing a deep dive into the structure, you just tell the structure, give me a serialization of it, and then you compare the serializations. I can understand that. So this will be split once, and then we're gonna just panic, I guess. So unwrap if it's not something, and then we're going to map it. No, map and then unwrap. So we get start and end. Unwrap. That's right. Location's got a line number and column number. These should be here, but I need to parse them. So let line number equal line number dot parse dot unwrap. Same thing with column number. It's great, especially for stuff that would otherwise take a whole ton of effort to maintain. And then when you first run the test, it spits out a new snapshot and you can mark it as okay or not. So it's like a cache. So you only need to really do 1/2 of the serialization because you pre-serialize the expected output. That's pretty cool. Settings noise is because the insta gets the test name from the containing function, not the test function that the test case generates. Sounds like a cool optimization. Okay, so I can turn into location. So yeah, what's this, by the way? Advance. Do we not use the character? I guess that makes sense. We didn't need to use that character. Okay. Yes, my idea was like not to actually have that in there at all, but have this be a tuple and like do the into internally. So yeah, let's copy this stuff. So that's a 3 and that's a 4. Okay, so this is not a location anymore. It's do I have to say static string? I think I do, but I'm not sure. So anyway, we need to actually map. So let this equal this dot into iter dot map something start token end dot collect. Ugh, stop moving around when I click. Where and what the heck? Okay, enter. There we go. So let well, it's really just start into token end into. Really? I guess so. I don't like how the test case actually keeps moving things around on me. It goes up and down and up and down. It's adding these lines in here, but it takes them away the moment I do a syntax error. Puts it back once it's parsing correctly. Okay, this more than anything makes me think I should have a helper to do this part, right? Thing is, if I put this stuff into a helper, and if I put the assert into the helper, will that obscure which test failed? I don't know. Don't really know Rust, but could you impl from that for location? Well, locations, each one of those things, this is one location. So there's two locations, is the beginning and end of the token. But yeah, I could implement from that to the other thing and then put that in there. I could give this a formal name, right? Do I use that in all the tests? I think I do. So maybe it's worth it. It might be worth it, right? The other thing I could do is I can get rid of all these two strings. Where were they? Okay, not all of them. Maybe I can get rid of these two strings too, right? Yeah, I don't know how much massaging I want to do right now. Maybe just because I only need to get through this much stuff, and maybe it's not too bad the way I have it now. Okay, let's insert this everywhere because they're all vec tokens, right? That need to be turned into a vector of tokens with locations. This is probably a bad idea to be copy pasting boilerplate, but I don't know. It's one of my weaknesses. What can I say? It's not too bad. Oh, we don't have expected output for those, do we? Those are specific tests. Here we're back to test cases. There we don't. Okay. And then that takes the place of token for a lot of these. And that was a misclick. Okay, try again. There, paste. Okay. A lot of the times I end up fighting my editor and I don't take time later to like think about how I was fighting my editor and how I could make my use of the editor more efficient and less confrontational. I kind of get like super focused. There. Okay, now everything's broken because these all need to have position strings in them and with forming into a tuple. Actually, pretty much all of these where we have vec token, let's just select them all and just do a beginning 0:0, comma. That might hit a ton of them, right? And then what if we take all the places where we have this combination, go one over, then one right again, comma, and then another 0:0, end. That actually got a lot of them in one fell swoop, didn't it? Where this didn't work, we had an extra. Okay, look at that. We've got all the way down to here. Some of these numbers are all wrong though. They're not 0, so that's 3, 4, and 5. Okay, and all of these are 4. Not all of that. 4. Actually, this one's a 5. These are 4 though. And that's a 5. Okay, moving on. These are 4. And almost had a multi-cursor success story there. 5. These are going to be all over the place. That's a 3. 5. 5 again, and that's 7. 4. 4. 1, 2, 3, 4, 5. This is 6. 6. Okay. Getting there slowly but surely. Okay, this is going to be weird because we have multiple tokens, right? So I need to be careful here. This end tuple, begin tuple, that again. Actually, and then I'm going to take all the characters between there and there, and here, 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 and here, we're going to paste. And then because this is going off the screen, I think I will break this into different lines like so. Actually, let's do a multi-cursor version of that. Enter, and then word jump. Enter word jump. Look at that. It's beautiful. Okay, let's fix up all of the end. So 0, 1, 2, and that's 3 to 5. This is a bit tedious, but yeah, now I'm kind of glad I did it now, not later. It would have been better if I did it at the time though, right? Actually, all of these are going to be the same, right? Yeah, I guess we're counting tabs as one character. Do I care that we're counting tabs as a single character? I think it's fine because who knows how many columns a tab really is. Carriage return, no, I wanted to ignore them completely. So what I wanted to do with this was to say that this is 0 to 2 and then 2 to 4. Because I don't want a carriage return counting as a column. And this one's special because that should go to the next line. So that should be a 1, 0 to 1, 2. And same thing for that other one. The 0 to 1, 2. Okay, this one is different. This is 0 to 2, and then there's a new line, and then that's 0, 1. So it's 1, 2 to 1, 4. See, now we're testing the Lexer line location tracking and integer parsing at the same time, sort of. Okay, so this one's 0, 1 to 0, 3, and this one's 0 to 0, 2. I probably made some mistakes, but that's how it goes. Yeah, Miscavige, when I start realizing that I'm doing a lot of repetition, I'm like, can't I do multi-cursor? Okay. So that's 6, 6, and 7, right? Okay, all of these have an extra string in them. With an in parentheses. There we go. If is 2, this is tedious. 6, 4, 3. Oh, how did I get extra spaces in there? Fix that. 5, 2. This is taking up all my morning. Just doing I should have had the stream title be adding locations to Lexer. It shouldn't say anything about grammar. I wish I could change the stream title and have it automatically update the VOD. You know, it's a pain that like it just takes a snapshot of the stream title at the very beginning of the stream, and so if it's wrong, tough luck. Okay, more of this stuff. Let's just do a lot of control Ds. Or for me, it's command D. Comma 0 colon 0. That. Cool. Actually, a lot of these are going to be 2 or 1, right? So what if I do this? Select all of them, and we'll just assume that... Actually, a lot of them are going to be 1. So what if we just change them to 1? And then look for the 2 character operators. Okay, here's 1. Actually, all of the beginning ones are 2, so that makes it easy. All the ones down to here are 2. Nice. Okay, almost there. So this is 2 tokens, right? To 0, 1. And then from 0, 1 to 0, 2. There. Cool. Next. Collect. How come we're not getting an error for that? Shouldn't I get an error for that? I'm not getting an error for that one. Or this one. Weird. I probably will, but these errors are probably obscuring the other ones, right? All my bad strings have a extra location. Okay. Beginning of... Why are you not going to the beginning of the line? There we go. Okay. That's 2 characters. That's 5, 5, 6, 7 characters. Five, 6, 7, 8, 9, 10, 11, 12, 13 characters. And that the next one's also 13 characters, right? I think so. Actually, all of these ones here are 13 characters. this one's a bad string. Actually, what are we matching here? I guess we match the whole regular expression. So, um, oh wait, these aren't 13. These are not encoded because it's a raw string. Neither is this one. So wait a second. It's 1, 2, 3. Actually, this will tell me, right? 2. This will actually count for me. 14. And these ones are 16. Okay, and this one is 16 also. Actually, all of these are 16, right? They're all raw strings. They're all 16 characters. Okay, that's 9 and 10 and 11, right? I'm feeling the tedium. Definitely feeling it, but we're getting there, right? Powering through this. We can do this. 9. 10. I have a lot of test cases for broken strings. 11. 8. 7. And the next one's 6, right? Yeah, 7 and 6. Okay, so this one's not a raw string, so that's one character. And I think we don't count the new line, so that should just be a 1. And this is a 1, also a 1. Okay, this is 2 tokens, right? So let's break it. The first one is 1 character. And the next one's on the next line starting in column 1. I hate it how it's jumping around. It's bugging me. 0, 1, 2, 3. Okay, and then this one's also 1 character. Okay, this is 2 tokens also. It's trying to get on my nerves with the jumping, but I'm not going to let it. This is also column 1 to column 3. Ah, stop it. Oh, followed by another one? Okay. Zero, 1, 2, 3 to 4, right? Okay. So not a raw string. So that's 1, 2. So it's 2 characters there. This is a raw string, so it's just 1 character on terminated string. And then this one, it's 1, 2. Actually, I can just have it count. It's exactly 10. So that globe should count as 10. Okay. We made it through all the strings. Okay. The illegal token here was the $, so that's just a single character. Why did it not? Oh, because it's I have a tuple in there. Oh, this has to be an into. Okay, and then empty is empty, right? So this is location token location. Okay, now the syntax errors I thought I would get, but I didn't. All of these need to be intos, I guess. And then these don't have markers at all. Okay, so we're all on line 0, but different columns. There, and there, comma, something, end. Oh, and these need to be intos. Okay, and that's unfortunate that it broke that one, but not the others. Anyway, so the X is a single character. Okay, actually the comment is all on the next line. So this is line 2, right? The assign is 1 character. And the integer is starting on 2, 2 to 2, 3. Okay, getting there. Almost done. One more. We can do this. Multi-cursor hell. Put a cursor there, please. There we go. Into. Okay. There, there, and there. Comma. Into that. Oops and oops. The X is 1 character long. Then we're on line 1. And this is at column 2. This goes 1, 1, and this goes to 1, 3. Thank God. Okay, we're done. Let's run all the tests. Can I run all of them from just this module? I can. Look at that. Test failed. 14 tests failed. Got a lot that passed. Some of them panicked, though. Attempting to subtract with overflow. Oh, no! Okay, so I messed up somewhere. I guess we'll just pick a test that failed. Block comment. Why not, right? Here we go. Block comment. How is this failing? I don't know. Run it again because it got too crowded there. Panicked attempt to subtract with overflow. Let's do debug. I don't do this often enough. There's our panic. Can I make this taller? How about if I get rid of watch? There we go. There we go. Okay. But I can't look at... Oh, can't look at token. What about... How come it's not... Oh, I guess we need to go deeper. Here we go. Byte number 12. Span start is Span in is 14. Span start's 13. Byte out numbers... Oh, shoot. That is going to... So yeah, I don't want to do... Sorry, then I don't want to do a byte minus byte number there. Yeah, that's right. There we go. I don't want her in while I'm streaming. She'll get food in a little bit. Just 15 minutes. I don't want the cat in here while I'm streaming anymore. Is that it? Let's see. Just go back to where I was. Yeah, here we go. And it still fails. But it fails because the numbers are off. So how are the numbers off? It thinks I'm in column... Oh, I didn't reset the column number? Is that the problem? We forgot to reset the column number. When we get to another line. So that's at the top, right? So a new line should go to column 0. I did go to column 0. And then why does it think I'm in column 3? Oh, probably we didn't advance the byte offset. Byte should go to the end of the span, right? Byte number equals span.end. Okay. There we go. Hey, we passed the test. All right. That's why we have unit tests, right? Let's run them all. Now we're down to 3 failed tests. So op and this one's failing. Oh yeah, that is 2 characters. Look at that. So is this one. Up to the top, run our tests. 1 failed test. Specific white space test. Where are we going to find that? 42. I should have given these names so I could find it more easily, right? It's 4267. Where's 67? Here we go. This is probably it, right? Nope, not that one. Not that one. It's one of these, though. Oh, that's the one. So this test case fails. Okay, so it's probably failing because I am counting a character turn as a character, right? Yeah, so this is going to need a special case, right? So I need to not count a character turn specifically. Don't we need, can't we do that in the advanced thing? So like when we get to this advance, wouldn't I like at this point use the character? So I'd say like if C is not equal to character turn. I think that's what I want. Right? Let's try the test again. Where exactly was it? Here? No. I don't know where it was. It was wherever I had a character turn. This one. It's still failing. That didn't fix it. Okay, so let me think about this. It still counted the column for some reason. Probably 287, right? What if I put a breakpoint in there and run in the debugger? So like we'll put debug breakpoint there, 287, and just say debug. Okay, so we don't need this. So what are we looking at here? Offset in bytes. So offset 0 byte is 4. Skip over, right? Oops. I guess I don't want to skip over. I want to step in, right? Step in. So now we're in column 1. Column 2. I can collapse all this, right? Okay. So that was for the 42. So let's run again. And then now we're on byte 3. Why is it seeing a C again? Did we not advance? Wait a minute. The position's 4267? No, there's a character turn in there. It's invisible. It's invisible even in the debugger. What's, how come we didn't advance the position? Because I forgot to advance the position. That would be why. Why didn't that not break anything else? I didn't advance self position like I should have. This position, right? Find all references. There's where it's declared. There's where it's initialized. There's where we iterate from it. So line end, we do advance it. Okay, yeah, I didn't. So it would have broken anything midline with multiple tokens, but we only had one failed test, which is odd. Anyway, yeah, so we need to advance the self position and every time we get here, right? Well, actually, I guess on return we can do it. So we know the offset. Let me think about this. Can I sample the position? Can I update the position? Can I sample the character indices and then change it? I don't think I can because this borrows, right? That borrows from self. So we kind of want to do it on it when we get out of here. I guess I can break. And then out here, I can say self.position equals self.position bytes. Like that, right? Yeah, let's try that. So don't need that breakpoint. Let's just run all the tests. They all pass. Awesome. That's what I like to see. All my tests passing. Cool. Okay, back to the parser. Actually, I probably got a lot of broken things, right? Really? Hold on, I didn't update the parser. How is it actually working? Sure. How about these tests? Wait, how does this work? How does the location? How is the location? Oh, I know why. Um, yeah, it's in not lib. It's in this parser, right? Actually, it's the fact that I'm using unit, right? No, wait a minute. We are getting. How does this work? Oh, we're not using the real. We're not using the real Lex. We're not using the real Lexer. That's why. It's a unit test. It's such a great unit test that for the parser that it doesn't even need the Lexer. It just uses tokens and then like unit for the beginning and ending. That's funny. I thought I would have to update my parser's test to use locations, but I don't because because the expression parser, yeah, we can't. It's generated code. It works for any type. That I could put like 42 and 67 here and it would still work. Right? As long as I put an I64 there. Maybe not. What's the problem here? Oh, somewhere else there's a unit. Blah, 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 blah. Not seeing it. Wait. It found. Oh, no, no, I'm wrong. I'm wrong. I'm wrong. I'm completely wrong. There is a place where we say what the location type is. And that is in the grammar itself. Yep. It is right here. So yeah, I will need, because the grammar needed me to say what the location type was here. It's not generic like I thought it was a second ago. It's definitely not generic, so I need to use our Lexer's location type. Now I still don't need to use the Lexer itself. I'm just using the Lexer's types. Right? now that'll break all the unit tests because they're going to want actual locations. I'm surprised it didn't break it already. Yeah, I think it's just we need to save again. Yeah, now they're all broken. See that? So they're expecting Lexer locations, not units in here. So I can put whatever location I want in here, right? Let's put a different... So because we don't want to make sure the location is what we expect, it's either the beginning or the end, right? So let's put a location. We can leverage this, right? Oh, guess who needs to let the dog out? Raimu has to let the dog out. It doesn't know what the type is, so I have to actually say it's location. And that we have to import it from the Lexer. Yeah. Now it's still wrong? What? Grammar. Oh, we're up here. Sure. Actually, let's turn that into static string, and then we'll do the same trick I did here, around here, this thing. Oh, this isn't going to work very well, is it? Actually, this is a result. So this is not even, I don't even want this. Hold on a second, I gotta let the dog out. Actually, not sure she needed to go out. I think she's just chasing something. Okay. Yeah, we'll just make... I won't do that trick here. I'll just do location. And we'll just have to put something up here. We'll just have to put it into there and suck it, right? Okay, and then, actually, can I run this by itself? I can't, because it has to compile the whole module, so we have to fix the other things too. This goes here, and I bet you this is a 1 there. And a 1 there. Run it. Didn't compile because there's no default for location. Oh, we need to have a default location? And that's the grammar generated that. What's our default location gonna be? Will it be 0, 0 if I just let it be derived, right? I'll just do that. Yep, that's where we are. Run that. Expected unit, where line are we on? Look ahead parser. So to compile this, we have to fix all of the compiler errors. So I've done 1 out of 6 of them. It's obviously wrong if it comes up in an error. You do size max, size max? I was just thinking 0, 0 would be fine. That's like saying, like, oh, we don't know. Go to the beginning. It's somewhere there. Wait, what? Oh, that's not the error. The error's down here. Copy from here. Do we actually need to say that, or is it going to figure it out now? It's going to figure it out. Perfect. Okay, location. Import. Cool. That. Oh, guess he needs to let the dog in again. That's my job. I am the dog letter in and the dog letter out. And I gotta get ready for work too. I don't know if I'll get this done in time. Well, hold on. I'll let the dog in and then we'll think. Okay, I have a feeling that all these intos and things that like I should have invested more time in test infrastructure. Because I don't know if I'll have this done in time. Maybe we can if I go fast. Go fast. Stress. Blah 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 blah. 1 location, save import from there. 0 and 1. Okay, getting there. Location, import from there. That's a 1. Not that. That. Using multi-cursor when I can to go faster. Ah, I lost what I had in the clipboard. You gotta hate that. That and that. That's a 1. That's a 1. These don't really add anything, do they? But I kind of have to do it. Just to verify that the locations are getting through. Almost done. Cool. So can I just run? Can I go Clippy? And can I just run the... Can I run tests? Oh, we have 1 failed test. So one of the tests that uses the end, I guess that makes sense, recognized end of file at a certain location. So it's in the right paren missing test and op ID. Where's it op ID list? Yeah, this one, right? This one should be a 1. We did it with I don't know, I'm going down to the wire. Can I run all my tests? But only libraries, not doc tests. 27 tests, all passing. And 116 from the Lexer. I wonder if I should put Lexer tests there. Well, I guess it does say Lexer up there. And down here it will say parser. So that's good enough, right? Okay, cool. I didn't expect that I'd take up the whole stream doing the integration of locations into the Lexer, but that's what happened. So, you know, things happen. But now, how do I summarize this? How do I summarize this? I guess that our Lexer returns location objects now for every time it parses a token, and that tells us the line and column number of every token. And then the parser uses it here so that when we get things out of the parser, like here, that we actually for error messages, it's mostly for error messages, right? For error messages, we know exactly the line numbers and column numbers where errors happened, which I guess is a great thing. For non-errors, we don't get the locations out because we didn't need them. If I wanted to, I could have included the location, right? If I had in the grammar itself, I guess if the if we wanted to, we could have put the locations into the abstract syntax tree if we needed it. And I think for some of the things I'll end up wanting to do that, right? Actually, if I wanted to do that, how do I get the location out? Well, I would probably have to build it into the token itself, right? The token would have to have the location in it somehow. Or maybe there was a way to get the location out, so I could have done it in the parser itself here, right? Oh, wait, no, that was the Lexer. Yeah, so in the Lexer, if we for some tokens, if we need the location, we can get it here when we do the next. Yeah, because we have the location here. We're tracking the location anyway, so actually we're returning it. Since we're returning the location, if the token also had the location in it, we could build it in because we were calculating it anyway. We have it there, right? But we'll get there when we get there. I need to refactor this. Like, I think this location stuff should go in its own module. I think this module should start with Lexer and not have this location junk in it. Because that has nothing to do with tokens or the Lexer at all. It's just dealing with strings, bytes, characters, and that's it. But I don't have time to do that now. I gotta go. I gotta go. Also, there's like a little bit of green fuzz there. Why is that? I thought I fixed my camera. My morning, is it my morning filter? Is okay. The evening filter is bad. The morning filter is not quite right. Is the color on that wrong? Yeah, the color on the morning filter is wrong. Okay, I think that fixed it. My thought process bleeding out. I mean, it could have been, but fortunately, it was just the color on my color filter. Okay, who to rate? Wow, the usual suspects are not streaming right now. I don't know. Visual Code? Visual Studio Code is having a release party? And only 26 people are watching? I wonder what that's about. You'd think that there'd be more than 26 people watching VS Code release party. What version are we on? They're having a 1.86 or 83 release party. We're on 1.83. Why are they having a release party for something that we already have? Must be a day ending with Y. Good one. I don't know. Shellcodes is going. I guess we'll raid Shellcodes. She is working on Ruby Rails, tooting around with Mastodon. Okay, well, I'll be back tomorrow. Hopefully to actually work on the grammar and not mess around with locations in the Lexer. So see you then. Bye.